In section 9.3, we're going to learn how to solve a certain type of differential equation called a separable differential equation. You'll be happy to know this is the easiest kind of differential equation that there is to solve. And for more difficult versions, you can take differential equations the course. All right, so a separable differential equation is one that has a really easy strategy to solve called the separation of variables technique. That's what makes it so easy to solve. This can only work for first order differential equations that can be separated. Now, just a reminder, first order means that the highest derivative available in the differential equation, derivative, is a first derivative. So we're not going to do a second derivative or any of that stuff. First derivative only, which is good because it gets more difficult, you can imagine, with second and third derivatives. All right. A separable differential equation is one that can fit into this pattern, where you have some function of y times y prime of x, which is equal to h of x. In other words, you have some function of y dy dx is equal to h of x. Or you can do it with t. So I'll fit it down here. G of y dy dt equals h of t. T and x are very commonly used as the independent variable. Actually, t is more frequently used. All right, so our first example is going to be to determine whether these are separable differential equations or not. Okay, well, if it's going to be separable, we can fit it into a form such that the dy dx and the y part are together. Okay, so let's see here. Now, at first blush, this might seem like it has a problem because there's that subtraction in there. However, let's rewrite this. This is dy over dx equals y plus 2. So we could divide both sides by y plus 2. Over here, we'd have 1 left. So it'd be 1 over y plus 2 dy dx equals 1. Right? Because I'm dividing both sides by y plus 2. So then this is a function of y, so that's g of y. This is y prime, and that is a function of x. I mean, it's a boring function of x because it's constant, but it works. This is separable. All right, now what about this one? Well, we're going to have problems. This is not going to be separable. See, because if I try the trick I just did, where I divided by y, right? So I divided by y plus 2. So if I try to divide by y, or even y minus 2, I'm in trouble here. So y will cancel out of this one, but it'll leave me x, which is great, minus 2 over y, which is not great. So I'll have 1 over y over here, right? Because I'm dividing everything by y. So if you will, I'm dividing this by y. So I'll have 1 over y equal to x minus 2 over y. 1 over y times dy dx equals x minus 2 over y. And you might think, oh, add the 2 over y over there. Well, sure, but the problem is then you have 2 over y plus a 1 over y dy dx. Remember what it says. It says the whole thing has to be multiplied by dy dx, not just the 1 over y part. So this is no good to us. This is not separable. I could not get it into the form. I have a function of y plus another function of y dy dx equals h of x. It's like I have an f of y up here tacked on in front, and that is not this form. All right, so let's assume that it is in that form because I would not give you any that are solvable, unless you're on a worksheet, in which case maybe that might be the question is it solvable or not? Is it separable or not? All right, because if it's separable, then you can solve it. If it's not separable, there's nothing else you can do. All right, this one is separable, however. So I want to get the y over to the other side. So I'm going to multiply both sides by a 1 over y. Technically, you could do negative 1 over y. It doesn't really matter. So that'll leave me 1 over y dy dx equals 1 over x. A negative 1 over x, sorry, because there's a negative. Well, this is great. This is the form. There's g of y, there's y prime, there's h of x. This is the separable differential equation form. So that means that I can solve this. I'll just make a note here. Right here. G of y, y prime of x, h of x. Separable. Woot. Makes us very happy. Matter of fact, I'll put a little woot next to it. Woot. All right, so how do you solve these? Well, what you want to do is get the differential out of here. So it's 1 over y dy equals negative 1 over x dx. I multiplied both sides, if you will, by dx. Why did I do that? Well, because then I can take the integral of both sides. See? So the integral of 1 over y is the natural log of the absolute value of y equals the integral of negative 1 over x is the negative natural log of the absolute value of x plus c. You really have a c here and a c here, but since they're both arbitrary constants, you can just put them together on one side. It doesn't really matter. All right, so then I want to solve this explicitly for y. So I want to get y by itself. So I need to get rid of this natural log. And of course, the way to get rid of a natural log is to exponentiate both sides. So I'm going to take e to the and e to the on the other side. E to the natural log of y is just y. Now, e to the negative natural log of x is not negative x. This is e to the natural log of x to the negative 1, right? Plus c, and that c is up in that exponent. All right, well, this is x to the negative 1, right? Now, what about this? Well, this is e to the natural log of x to the negative 1. I'll give it one more step, times e to the c, right? So, I mean, if you want to call this, C1 or C2 or something like that, that's fine. So it's e to the c because of a to the b plus c is a to the b times a to the c, right? Power properties. But this is some arbitrary constant, right? So I can just call it c. So this is x to the negative 1 times c. I mean, if it makes you happy, you can call this like C1, 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 and this one's actually C2. You've modified it. It's no longer the same constant it would have been here. But that's okay, because it's just some arbitrary constant anyway, so we don't really care. So that means that y, my equation, is c divided by x. Because x to the negative 1, of course, is 1 over x. If you want to write it as c times 1 over x, that's also fine. Fun, huh? So to reiterate, you get it in the separable differential equation form, which basically has the y's and the dy's on one side and the x and the dx on the other side. Then you integrate both sides, and then you solve it for y, if you have to solve it explicitly, which in general we do, unless it says an implicit one. All right, let's do it again. So over here we have, let's see here, y prime equals y squared square root of x minus 5. So I could divide both sides by y squared, right? Get the y over to the other side. So that'll give me 1 over y squared times dy dx is equal to, I'm going to rewrite this as x minus 5 to the 1/2 power. But look, this is a g of y, this is a y prime, and this is an h of x. It's separable. We just separated it. All right, since it's separable, that means that we can find the integral, but first we have to get the differential dx out of there. So it's y to the negative 2. I'm just going to rewrite that since I know I'm about to integrate it. I'd be happier with the power rule. So y to the negative 2 dy equals x minus 5 to the 1/2 dx. All right, when I integrate both sides, the integral of y to the negative 2 is negative y to the negative 1, and that equals, and then when I add 1 to this power, it becomes 3/2. So I put 2/3 x minus 5 to the 3/2 plus c. So you slap on a constant over there. All right, well, if I want to solve this explicitly for y, this is negative 1 over y. Actually, let's kill two birds with one stone here. So it's 1 over y equals negative 2/3. See what I did there? I didn't feel like dealing with the negative, so I multiplied by a negative as well as rewriting it. But of course, if 1 over y is equal to this, then that means that y is equal to 1 over all of that. And your c is in that denominator. All right, it got moved down. The whole thing gets moved down. You're basically taking the reciprocal of the whole thing. In fact, you are taking the reciprocal of the whole thing. And then the fraction inside a fraction, this is actually okay. But if you want to be a little bit cleaner about it, we'd write negative 3 over 2 times x minus 5 to the 3 halves. Because, of course, 1 divided by 2/3 is 3 halves. And there you have it.